Hello everybody, welcome into another lesson. So today we are going to talk about pyramids. The last lesson we talked about prisms where it had two bases. Prisms always have two bases, and then depending upon the number of sides you have in the prism, that's how many faces you have. Well, you have here a pyramid where, unlike a prism which has two bases, a pyramid only has one base. Today, for simplicity's sake, we're only going to talk about square pyramids, which will make life a lot easier for all of us. But also, like prisms, the base of a pyramid could be any shape. It could be a square, a rectangle, a triangle, a pentagon, what have you. We're only talking about right pyramids also. There are such things as oblique pyramids, but we're only going to deal with right pyramids. But of course, here you have the base of the pyramid being a square in this case. And then you have the height coming down from a point called the vertex of the pyramid. It goes down to the center of the base. Now, the height is denoted by h. Okay? Now, your faces, you count how many sides you have on the base here, which would be 4 since it's a square, which means you'll have 4 faces. But since you only have one base and your faces intersect at a point above the base called the vertex, the faces of a pyramid are always congruent isosceles triangles. So, having said that, we also have what's called the slant height that goes from the vertex of the pyramid down to the midpoint of one of the bases, and it's also in altitude with one of the sides of the bases. The slant height is called L, not to be confused with the height of the pyramid. And the reason I'm mentioning triangles for the faces is because that slant height L is the height of the triangle, which you're going to need to solve to find such things as the lateral area, the surface area, and the volume. Now, to find the lateral area of a pyramid, which is the area of your faces minus the base, you don't count the base for the lateral area, it's going to be equal to half the perimeter of the base. So half the perimeter of the base times the slant height. It's derived from the formula for an area of a triangle in general, which would be half the base times the height. Well, this formula for the lateral area allows you to take care of all the triangles at once, times the slant height, of course, which would be the height of each triangle in particular. So the lateral area of a pyramid is half the perimeter of the base times the slant height. And then the surface area, which is the total coverage of the solid itself, is the lateral area plus the area of the base. And then, of course, you have the volume, which is 1/3 of the area of the base times the height of the pyramid. Now, where do we get 1/3 from? The idea is, if I took this square pyramid and put it inside of its cube, which is a square prism, essentially, you could fill it 1/3 of the way full, and it would take 3 pyramids to fill the prism. That's where that 1/3 comes from. Same is true if I had a rectangular pyramid. I'd have to put 3 of those inside of a rectangular prism to fill it up, or, what have you. So, we are going to do some examples here. This shouldn't be a terribly long lesson, but there are some important things to discuss when dealing with pyramids. Alright, so let's go ahead here. Let me draw me a pyramid here. Perfect. All right. So I got me a pyramid. There we go. There's a square pyramid. Let's see what they give us for these examples here. They give us that a base edge is equal to 6 units. So edge of the base is 6 units for the square. And then the height of the pyramid itself is going to be 4. So we have the height, which is equal to 4. What we need to find are the slant height, the lateral area, surface area, and volume. So, okay, well, here's the thing. We know the height, we know a base edge. In order to have any hope of even finding the lateral area, we definitely need to find the slant height. So, here's the thing about trying to find the slant height. The slant height itself comes down from the vertex of the pyramid to the center of the side, to a center of a side, and divides the isosceles triangles into 2 congruent right triangles. So if I want to try to solve for the slant height, I'm going to have to do some Pythagorean theorem or some other work here. So let's go ahead here, find the slant height. Now, we can draw from the center to where the slant height meets the opposite side. We can draw a perpendicular line there, making this a right triangle. But here's the thing. In order to find that, we're going to have to know some other things here. So what we need to do, because this leg of the right triangle is essentially the apothem. Before we can even solve for that, what we need to do is try to find also the radius of this square. And then, of course, the apothem goes from the center to the midpoint of the opposite side. Now, what is the central angle of a square? Take 360 divided by 4, you should get a central angle of 90. So in other words, this should, when you draw the apothem, it should bisect that 90-degree angle and give you 2 45-degree angles. So really, you should have a 45, 45, 90 right triangle. Well, here's the thing, right? The whole base is 6. If the apothem goes to the center of the opposite side, that means it divides the base evenly. So the length of this one leg here is 3. It's a 45, 45, 90 right triangle. The apothem's the other leg, and it's equal to the first leg. So you would have an apothem length of 3, which means this leg here also being an apothem is 3. Now I've formed a right triangle here between the height, the slant height, which would be the hypotenuse, and then this leg here being the apothem of the square. I can do Pythagorean theorem. We'll denote the slant height as L. That'll be the length of the slant height. So now I can take the 3 squared plus 4 squared, set that equal to L squared, where then I would get L squared equals 9 plus 16, which means L squared equals 25, which means my slant height L would have a length of 5. So now, since I found the slant height, I do have a prayer of being able to find the lateral area, the surface area, and the volume. So of course, the lateral area of a pyramid is equal to half the perimeter of the base times the slant height. Well, we need to find the perimeter. What is the perimeter of a square? You just take one side and multiply it by 4. So what's 6 times 4? That's 24. So the perimeter would be 24 times your slant height of 5. Well, now, what is half of 24? That's 12 times 5 is 60. So I get a lateral area for this pyramid of 60 square units. Now, I can go for the surface area, but first I need to know the area of the base. What is the area of the base, being a square? The area of the base, of course, is just a side to the second power, which would equal 6 to the second power, which means the area of the base is 36 square units, since it's a square. Now I can find the surface area. The surface area, of course, is equal to the lateral area of the pyramid plus the area of the base, which the lateral area was 60 square units, then the area of the base was 36 square units. So I should get a surface area of 96 square units. So the surface area of this pyramid is 96 square units. So I got the lateral area of 60, the surface area of 96, I just need to find the volume. So the volume is equal to 1/3 of the area of the base times the height of the pyramid. Well, what was the area of the base? The area of the base was 36. So that'd be 1/3 of 36 times the height of the pyramid itself, which was 4. So what's 1/3 of 36? That'd be equal to 12 times 4, which means my volume should be 48 cubic units. So the volume of this pyramid would in fact be 48 cubic units. So sometimes you're only given a couple pieces of information. You got to find the third piece of information that you need in order to be able to solve for everything else that you need. And I got a few more examples here. I'm going to leave the 45, 45, 90 up for a reason. Alright, what are we given next here? So we have a base edge with a length of 16 units. And then they give us the slant height for this, which is 10. So this time we know a base edge, the whole thing to be 16. We have a slant height of 10 units. Well, again, we're going to need to find the height this time. We got to find the height, because all we know are a base edge and the slant height. We don't actually know the height itself, which will be denoted by h. Well, in order to find the height, we're going to have to play with some right triangles. First, draw your radius from the center of the square to a vertex of the base, and then from that you'll draw the apothem to the center of a side from the center of the square, and you have another 45, 45, 90 right triangle, right? Okay. Well, if the apothem divides one base of the square evenly, that means a leg of this right triangle, or half the base, would be 8. And since it's a 45, 45, 90 right triangle, your apothem would also be 8. And this here in blue is also an apothem, so that's 8. So now we can go ahead and solve for the height by using Pythagorean theorem. So take that h squared plus that 8 squared, set it equal to 10 squared, which would give you h squared plus 64 equals 100, which gives you h squared equals 36, which would give you a height for the pyramid itself being 6. So the height of the pyramid is 6. Alright, so we found that now. The height is 6. Now that we know the height, we can solve for everything else. First, let's find the lateral area. The lateral area, of course, is equal to half the perimeter of the base times the slant height, which in this case, what is the perimeter of the base? You just take that length of 16, multiply it by 4 since it's a square, so the perimeter would be 64 times the slant height, which is 10. What's half of 64? 32 times 10 is 320. So the lateral area of this pyramid is going to be 320 square units. So yes, the lateral area of the pyramid is 320 square units. Now, before I can find the surface area or the volume, I need to find the area of the base. The area of the base is just the side to the second power, so that would equal 16 to the second power, which means the area of the base is 256 square units. Now that I know the area of the base, I can find both the surface area and the volume. So the surface area equals the lateral area plus the area of the base, which would give me a lateral area of 320 square units plus 256 square units for the area of the base, for a total surface area of, let's add these up, 576. So you would get a total surface area for this pyramid of 576 square units. So we found the lateral area, we found the surface area, now we need to find the volume. The volume, of course, is a third of the area of the base times the height of the pyramid. Well, what is the area of the base? Take 1/3, multiply it by that. That was 256 times the height of the pyramid itself, which was 6. So let's see, a third of 6 is 2 times 256. That would give you a volume of 512 cubic units. So the volume of this pyramid would be 512 cubic units. I got just 2 more exercises. Let's just erase some of these values here. Let's see what we get this time. Two more problems. All right, what are we given? We are given that the height is 12 and that the slant height is 13. So this time we know the height to be 12, we know the slant height to be 13. Well, we don't know what the side of a base is, and we definitely can't go further without that to even find the perimeter or the area of the base, let alone find the lateral area, surface area, or volume of the pyramid. Well, right away, you're going to want to solve for the apothem here. This blue leg between the height and the slant height is the apothem. We'll need to find that first. So take your a squared plus 12 squared, set that equal to the slant height of 13 squared, which would give you a squared plus 144 equals 169, which would give you that a squared equals 25, giving you the apothem to be 5. So now we know the apothem to be 5. Why did we solve for the apothem? It's going to come into play to help us find the length of a side, or at least half of it to start with. This here is also the apothem, right? And this is a 45, 45, 90 right triangle, so the apothem and half the length of this side are the same, which would be 5. And if half the length of this side is 5, that means the whole length of a base edge is 10. So now we found a base edge to be 10. So there is a bit to consider with right triangles. So the base edge is 10. We found the missing information we needed. Now we can go ahead and start solving for the lateral area and other things. The lateral area, of course, is half the perimeter of the base times the slant height, which in this case, the perimeter of the base being a square, that's 10 times 4, that'd be 40. So you would get half of 40 times your slant height, which is deemed to be 13. Well, what's half of 40? That's 20 times 13, that's 260. So you would get a lateral area for this pyramid of 260 square units. So we found the lateral area to be 260 square units. Now, before we go on to find either the surface area or the volume, we need to know the area of the base. The area of the base being a square, you're just going to take one side of the square, which is 10, raise it to the second power, which would give you the area of the base being 100 square units. Now that we know the area of the base, we can proceed to finding the surface area and the volume. So the surface area, of course, is equal to the lateral area plus the area of the base, which in this case, the lateral area was 260 square units plus the area of the base, which was another 100 square units. So therefore, the surface area of this pyramid is going to be 360 square units. So there's our surface area, 360 square units. Now, last but not least, let's find the base. Let's find the volume. The volume, of course, is equal to 1/3 of the area of the base times the height of the pyramid, which would equal 1/3 times 100 times the height of the pyramid, which is 12. Alright, well, 1/3 of 12 is 4 times 100 would give you a total volume of 400 cubic units. So the volume of this pyramid would in fact be 400 cubic units. Alright, I got just one more here. This one's different yet. Let's see what we're given this time. Base edge equals 16. Now this is different. A lateral edge equals 17. So we know a base edge this time to be, the whole length is 16. Okay? Now, a lateral edge is one of the sides of the isosceles triangles that are formed from the that are formed from the sides of the pyramid. So we have a lateral edge of 17. We need to find the height and the slant height both. Well, it would be true also that this side would be 17, since that's also a lateral edge. We can actually first go for... We could probably find the slant height first. Do you know why? Because... Well, of course, we don't know the slant height, but we know that the whole edge of the square is 16, so half of that is going to be 8, since the slant height intersects the, it touches the opposite side from the vertex at the midpoint of the base. So now between the slant height, this half of the base, and the lateral edge, we have another right triangle. So now you can just do Pythagorean theorem. So if you want to find the slant height, you'll take the slant height squared, L squared, plus that leg of 8 squared, set that equal to your lateral edge squared, which would be 17 squared. So then you get L squared plus 64 equals 289, which would give you that L squared equals 225 for a slant height of 15. So now we've identified the slant height to be 15, which really helped us a lot. Alright, so we know the slant height. We know the base edge. We still need to, of course, find the height. But in order to solve for the height, we need to find the apothem. Well, again, if half the base here is 8, since the whole base is 16, you have a 45, 45, 90 right triangle here. So that means your apothem is also 8. This apothem will be 8. So now between the height, the apothem, and the slant height of 15, we can solve for the height of the pyramid. So go ahead, take your height to the second power plus that 8 to the second power, set it equal to the slant height of 15 to the second power, which would give you height squared plus 64 equals 225, which would give you height squared equals, not going to be a fun number, is it? $161. So now we got to try to find the square root of 161. Which, I know it's not a perfect square, I do know that much, but does it break down into anything? Nope. Well, that gives you a height for this pyramid of 100, the square root of 161 units. So now we know the height, and sometimes you'll get answers like that for the height, or for other things you'll have ugly square root answers. So the height's the square root of 161. So now we know the slant height and the height, and we know the base edge. We can go ahead and start finding everything we need. So the lateral area, of course, is equal to half the perimeter of a base times your slant height, which would be half of, what is the perimeter of the base square being 16? 16 times 4 is 64, so that'd be half of 64 times your slant height of 15, which is not going to be pretty. The lateral area, so what's half of 64? That's 32. Then we got to take 32 times 15. which would give you a lateral area of 480 square units. So we found the lateral area to be 480 square units. Okay. Now before we can find the surface area or area of the base, surface area or volume, we need to find the area of the base. Which the base is a square, means you take that length of 16 to the second power, which would give you a base area of 256 square units. So now we know the lateral area and the area of the base, we can proceed to finding the surface area. The surface area, of course, is the lateral area plus the area of the base, which would equal 480 square units plus 256 square units. So now I just need to add 480 plus 256. Would give me 736 square units. So the surface area of this pyramid is equal to 736 square units. So now I can find the volume. The volume equals a third of the area of the base times the height of the pyramid. Ooh, this is going to be ugly. So that's going to equal a third of 256 times the height, which is the square root of 161. Which I do believe 256 divides by 3. I just want to double check my work there. I could be wrong, but no, it doesn't. Okay, well, so your volume in this case is going to be 256 times the square root of 161, all divided by 3 cubic units. So yes, that was a rather hideous volume problem, but the volume is 256 times the square root of 161, all divided by 3 cubic units. And yes, you will have those. So if you can solve for the apothem, and use Pythagorean theorem and other things to find the missing heights or slant heights or base edges, you got this. And then you'll be able to go from there, find your lateral area, surface area, and volume, and everything you need to find those. So that's it for pyramids. Next lesson, we're going to talk about cylinders. So I hope everyone has a great day. Take care.